In this lesson, we'll look at how to write electron configurations of atoms. Electron configurations are a condensed way of showing exactly where all the electrons are located in a species. These are also called ground state configurations, which just specifies that it's the configuration of lowest energy. To do this, we use two simple steps. First, you write down the subshell the electron is in, then write the number of electrons located in that subshell. You repeat this process until you have accounted for all the electrons in the species. Let's take the magnesium atom as an example. We know from the periodic table that the magnesium atom has 12 electrons. The first subshell to be filled will be 1s, which will be filled to the max with 2 electrons. Next will be 2s, also filled with 2 electrons. This gives us 4 electrons accounted for. Next is the 2p subshell, which is filled with 6 electrons. This now gives us 10 electrons accounted for. Thus, the 3s orbital will be the last orbital with electrons, and it will be filled to the max with 2 electrons. This gives us 12 electrons all accounted for. Let's take a look at phosphorus as a second example. From the periodic table, we know that phosphorus has 15 electrons. Just as with magnesium, the first 4 subshells will be filled to the max, giving us 1s2, 2s2, 2p6, and 3s2. This accounts for 12 of magnesium's 15 electrons. For the remaining 3, we must go into the 3p orbital, but fill it only halfway, with 3 electrons. A quick way to determine the electron configuration of a species is by reading the periodic table. The periodic table can be broken down into S, P, D, and F blocks. Note that the helium atom is part of the S block. To determine the electron configuration of any atom on the periodic table, you can just read through the periodic table from left to right and top to bottom. Let's take the aluminum atom as an example. We first have 1s2, followed by 2s2, 2p6, and 3s2. Now, reaching aluminum, we can see that it is the first element in the third row of the p block. Thus, the last electron is written as 3p1. It's important to remember that though the D block begins at the 4th row of the periodic table, the first D subshell is 3D. Thus, iron will have a configuration of 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d6. Now, as you can see, configurations of elements can get to be quite long. Thus, abbreviated configurations are often used. An abbreviated configuration of an atom involves only listing the subshells that come after passing the closest noble gas. For example, let's look at chlorine. The noble gas that comes before chlorine is neon. Thus, we can write the abbreviated configuration for chlorine is equivalent to neons, followed by 3s2 and 3p5. The abbreviated configuration for a noble gas would be just the noble gas itself. So the abbreviated configuration of argon is just argon.